Here, starting out a reference angle is a positive acute angle, positive being a key word here, positive acute angle measured from the terminal side of an angle to the nearest x-axis. Okay, a reference angle is a positive acute angle measured from the terminal side to the nearest x-axis. We have three examples right here. Notice we have an angle in the second quadrant. This angle might be measured as about 135 degrees. But as a reference angle, we're measuring that angle from the terminal side down to the closest x-axis, which would be this one. So our reference angle would be 45 degrees. And that will come back to those triangles that we've talked about in the last section. Another example here, our second one, you notice the angle is in quadrant 3. That angle might go all the way around and be a 225 degree angle if we measure it in standard position from here all the way around. But as a reference angle, we're measuring that from the x-axis to that terminal side. So once again, we would have that positive acute angle of about 45 degrees. And a third time here in quadrant number 4, angle comes all the way around, might be 315 degrees as an angle in standard position. But we are going to measure that angle as a positive acute angle from the terminal side to the x-axis there, or another reference angle of 45 degrees. And again, that's going to come back into play with those two triangles we talked about previously. So now, based on the triangles we looked at in section 1, we know the ratio of the sides for a 30, 60, 90 triangle and a 45, 45, 90 triangle. And we can use those to find our 6 trig functions of any reference angle there on the coordinate plane that would be a multiple of 30, 45, or 60. Start out with, we'll have some practice here of reference angles. Letter A says we have a 278 degree angle. If I were to sketch that very quickly, 278 degrees would be down here in quadrant number 3, just past the 270 mark. But we're going to measure that not to the y-axis or as a standard position. We're going to measure that from the terminal side to the nearest x-axis, and if we measure that as a reference angle, we're going to get a reference angle of 82 degrees. That's the angle measured from the terminal side to the x-axis. Starting over again with letter B, we have a 125 degree angle, or negative 125 degrees. So we measure that clockwise. 125 degrees would come over in this direction. The reference angle then is measured from the terminal side to this x-axis, and that makes our reference angle 55 degrees. So our reference angle here would be 55 degrees. Continuing on here with these last couple, 99 degrees would be just past the y-axis in a clockwise or counterclockwise direction, so positive angle. Again, our reference angle is measured from here to here, so our reference angle would be 81 degrees. Noting that all these angles here are positive acute angles. For our negative 1387, the first thing we want to do is find coterminal, so we keep adding 360 until we got there. And if we add 360 4 times, that will get us a 53 degree angle, which is our coterminal angle, or in this case, also our reference angle. So that's just some practice on getting used to reference angles. From here, we're going to use those reference angles to find some values of our trig functions. You can see letter A here is 210 degrees. So the first thing I'm going to do is try and sketch 210 degrees, which would be from here to here. As a reference angle, that is measured as 30 degrees. Going a step further, if I came straight down, I'd make a right angle here, which means this angle would be 60. Now we learned back there in section 1, and also from our geometry knowledge, that the length of the side opposite to 30 is 1, opposite to 60 is square root of 3, and the hypotenuse is 2. Something to keep track of is we are in the third quadrant, so the x and the y are both negative. Okay, so our x value is negative square root of 3, our y value is negative 1, and our hypotenuse is always positive, so it's 2. Once we have the triangle labeled, we can find our trig functions just by using that triangle. The sine of 210 degrees is y over r, or negative 1/2. The cosine of 210 degrees is x over r, or negative square root of 3 over 2. And the tangent of 210 degrees is opposite over adjacent, which eventually simplifies to be square root of 3 over 3. And then real quickly, our reciprocal functions, cosecant of 210 degrees is going to be negative 2 over 1, or just negative 2. The secant of 210 degrees, we'll go ahead and write it out the long way, negative 2 over square root of 3, rationalized by multiplying top and bottom, or numerator and denominator, by the square root of 3, and we get negative 2 square root of 3 over 3. Finish with a cotangent of 210 degrees, just flipping our fraction over, we have the square root of 3 over 1. So there's the first problem using reference angles to come up with our 6 trig functions of a different angle on our coordinate plane. Letter B here, negative 315 degrees. I'm going to start out the same way with a quick sketch. If I went around, 315 degrees would be out here in quadrant 1. That would give us a reference angle here of 45 degrees. We'll go ahead and come straight down to make our right triangle out of it. So now we have a 45 right triangle, and those sides are 1, 1, and square root of 2. Noting that we're in quadrant number 1, so x and y are both going to be positive in quadrant number 1. So very quickly, the sine of negative 315 is going to be opposite over a hypotenuse, or 1 over square root of 2, which if we rationalize gives us square root of 2 over 2. Cosine of negative 315 is adjacent over hypotenuse, which is also 1 over square root of 2, which simplifies to be square root of 2 over 2. And tangent of negative 315 is opposite over adjacent, 1 over 1, or just 1. Reciprocal functions very quickly. Cosecant of negative 315 is going to be square root of 2 over 1, or just square root of 2. Secant of negative 315 is going to be square root of 2 over 1, or just square root of 2. And cotangent of negative 315 is going to be 1 over 1, or 1. One more time with our reference angles. I have 120 degrees up here, so 120 degrees will be measured somewhat in this format. If we make a reference angle, we'll come straight down, or down to our x-axis here. That reference angle will be 60 degrees. We'll come straight down to make our right triangle, which means we have a 30, a 60, and a 90. And the length of those sides, then will be 1, square root of 3, and 2. Make sure we keep track of what quadrant we're in. We're in the second quadrant, so the x is negative, the y is positive, the hypotenuse is always positive. And then over here, we'll find our trig function. So the sine of 120 is y over r, or opposite over hypotenuse, square root of 3 over 2. Cosine of 120 is x over r, or adjacent over hypotenuse, which is negative 1/2. And tangent of 120 is opposite over adjacent, which is negative square root of 3. Reciprocal functions, cosecant of 120 is going to be 2 over square root of 3. Again, we'll rationalize the denominator, and we get 2 square root of 3 over 3. The secant of 120 is going to be 2 over negative 1, or negative 2. And the cotangent of 120 degrees, reciprocal negative 1 over square root of 3. Once again, rationalize the denominator, and we get negative square root of 3 over 3. So there's 3 examples, one using a 30, one using a 60, and one using a 45 of our reference angles to find some other values on our coordinate plane. So notice here we have pretty much the same idea. We have angles scattered around our coordinate plane. So cosine of 120 plus the sine squared of 60 minus the tangent of 30. See if we can't squeeze that in over here. I draw a 120 degree angle, we just had that above and said that reference angle was 60 degrees. Came straight down to make a 30, 60, 90. We have -1, square root of 3, and 2. Cosine is going to be adjacent over hypotenuse, so it is -1/2. From there, I'm going to put the sine of 60 in here. 60 is this angle from here. That's already a positive acute angle, so I have 60, 30, and 90. So I have 1, square root of 3, and 2. Sine is opposite over hypotenuse, square root of 3 over 2. Notice that's being squared. And just to simplify things down here a little bit, I'm going to use this triangle right here to find my tangent of 30. 30 is here. Tangent is opposite over hypotenuse, so it's 1, or opposite over adjacent, sorry. 1 over square root of 3, and again, that is being squared. I'm just going to leave it in the unsimplified version since I'm going to square it. That squaring will get rid of my radical by itself. If I do the work here, then I have -1/2. Square root of 3 over 2 squared. Square root of 3 times square root of 3 is just 3. 2 times 2 is 4. And minus 1 squared is 1. Square root of 3 squared is just 3. Notice here I have fractions all with a different denominator, so my common denominator there appears to be 12. That would give me -6/12 for my first fraction, 9/12 for my second fraction, and 4/12 for my third one. And -6 plus 9 minus 4 is -1/12 as we evaluate that expression. Moving on. Cosine of 60. I'm going to keep using my sketch up here at least as long as I can. 60 degrees is right here. Cosine is adjacent over hypotenuse, so that is 1/2 being squared. Looks like I have to draw the secant of 150. So 150 would be here, which would give me a 30 degree reference angle. And if I came straight down, I'd have the 30, 60, 90. Opposite of 30 is 1. Opposite of 60 is square root of 3. Hypotenuse is 2. We're in the second quadrant. Oops, I made a mistake there. Let's get rid of that. It is not a -1 over there. It's a +1. We have a +1 there, but I did put the negative with the x. The x is negative. Secant is r over x, so it's 2 over negative square root of 3. That value is being squared. I'm going to draw in one separate coordinate plane here to get our 210. 210 goes from here to here. Our reference angle then is 30. Come straight down. We have a 30, 60, 90, 1, square root of 3, and 2. This time, both x and y are negative. Cosecant is r over y, so it's minus 2 over -1 being squared. Doing the math work here. We have 1/2 squared, which is 1/4. We have 2 squared, which is 4. Square root of 3 squared, which is 3. And minus 2 over -1, or -2 squared, which is 4. I'll put that over 1 for visual effect. Do our common denominators again. Our common denominator is 12. Gives me 3 plus 16 minus 48. 3 plus 16 is 19. 19 minus 48 is -29/12. To simplify and evaluate that example. Okay, so next page to polish off. Maybe not polish off. I think we have one more with this. These are essentially working backwards. Find all the angles of theta, values of theta, if theta is an angle between 0 and 360 for each. So cosine is negative square root of 2 over 2. Over here to the side, I'm going to sketch in our 45, 45, 90 triangle and their sides. And I'm also going to sketch in our 30, 60, 90 triangle. So let's go 60 here, 30 here, and 90, 1, square root of 3, and 2. So as I look at those two triangles, only one of those contains a square root of 2. That's right down here in our 45, 45, 90. So that's the only way I'm going to get a square root of 2 as part of my fraction for cosine. Cosine being square root of 2 over 2, if I did a cosine of 45, I'd get 1 over square root of 2, which when I rationalize the denominator would get me square root of 2 over 2. So I have that value, but I want a negative value. So let's go a step further. Now that we've established we have a 45-degree reference angle, on our coordinate plane, cosine being x over r is going to be negative in quadrant number 2 and also negative in quadrant number 3. So as I measure that angle in standard position, or from 0 to 360, that angle would be 135 degrees, or it could be 225 degrees. Essentially what we've done is work backwards from our triangles to a reference angle to the actual angle itself in standard position. Okay, so then moving on to letter B, we have tangent of theta being undefined. For tangent to be undefined, tangent is y over x. That means undefined means that x has to be 0. If we think long and hard about our coordinate plane has a y value, or x value of 0 here on the y-axis here and here. This is 0 and 1. This is 0 and negative 1. So tangent is going to be undefined at 90 degrees, where we have 1 over 0, and at 270 degrees, where we have 0 over negative 1. 90 degrees and 270 degrees. So those are our two answers for tangent being undefined. Keeping our triangles in view here for letter C, cosecant of theta equals 2. Notice once again our 45, 45, 90 triangle, I have a square root of 2, but not just a number 2, so I can't get 2 in any fraction here. But up here, I can get 2 by putting 2 over 1, which means for cosecant, cosecant is r over y, or hypotenuse over opposite, which means I have to use the 30-degree angle as my reference angle. Okay? Once we have the reference angle, then I know that cosecant, being r over y on the coordinate plane, is positive in quadrant number 1. So I'll draw a reference angle in quadrant number 1. 30 degrees is one of my answers. Y is also positive in quadrant number 2, so I'll draw a reference angle in there as well, but I'll measure that angle in standard position, so that angle is 150 degrees. So those are our two answers for the cosecant equaling 2. Looks like we're ready to move to the next page. Actually, the next section, so we're done with that section, so we should be good.